All right. So now the instructions for this next page are to graph the progress of each person in the coordinate plane and use a different color for each participant. So because I need to use a different color for each person, I decided to make a little key down here. So Diego's green, Elena's orange, and Andre is red. That way it makes reading my graph a little bit easier. I don't have to write people's names on my actual coordinate plane over and over again. So, looking at our table and looking at the graph, I can see that my x-axis is the time in hours. And so, once again, they all share the same time in hours. So, here's how far they all go in 1 hour, 2 hours, 4 hours, 5 hours. Now, what's different about them is how far they walk in each hour. So, let's start graphing, and we're going to start with Diego first. So Diego is really nice because all of his distances per hour were whole numbers. So Diego, I can see, walked, in 1 hour, he walked 3 miles. So the x-axis is my hours, so 1 hour, it's right here, and then 3 miles. And that would be right here. Is Diego. And now we'll do Elena. So Elena is orange, and she went 2 7/75 miles in 1 hour. So that's a little bit more than 2.5. It's 2 3/4, so I'll put her there. And then Andre was 3.5. So he would be here for 1 hour. Okay. All right. Now let's do the same thing for 2 hours. So Diego walked 6 miles, so I have to go over to 2 hours, and then go up to 6. So here's Diego. Elena was 5.5 at 2 hours. 2 hours. Elena. And Andre was 7. So in 2 hours, I'm at 2 hours, and then gotta go up to 7. All right. And now 4 hours. So Diego walked 12 miles in 4 hours. Go over to 4. And then go up to 12. All right. And Elena did 11 miles in 4 hours. And Andre did 14 miles in 4 hours. So 4 hours, up, and 14. Okay, awesome. So, that's all the graphing I'll do there. You kind of get the idea. So I'm not going to go ahead and do the 5 hours. If you want to do that yourself on the digital applet, feel free. So now I want to look at the page after. Okay, so here's where our algebraic expressions start to come in. Okay, so it says Diego says that D equals 3t represents his walk, where D is the distance walked in miles and t is the time in hours. Explain why D equals 3t relates the distance Diego walked to the time it took. Okay, so once again, I'm going to just pull out that D is the distance and t is the time. So he's saying that he has to take, for whatever time, if he multiplies that by 3, that will give him his distance. So if that's true, let's see how far he walked in 1 hour. Let's say we were working with 1 hour. So then we're going to take that D equals 3, and then we're going to plug in 1 for the t, the time. And that's telling us that in 1 hour, he walked 3 miles in 1 hour. Is that true? Let's go back and look at our table. right here, Diego walked 3 miles in 1 hour. That is true. Okay? So that is true. Because lowercase d, Diego walks at a speed of 3 miles per hour. Meaning that you take the hours past and multiply them by 3 to find his distance. Okay, so once again, so that means that if he walked for 2 hours, and I plugged in 2 here, that would be 3 times 2, and that would mean he walked 6 miles in 2 hours, which, going back to our table, is true. So now we have to do the same thing for Elena and Andre. So, if we use Diego's speed in miles per hour, I'm sure we could do the same thing for Elena and Andre. So we know that Elena went 2 7/75 miles per hour, and Andre went 3.5 miles per hour. So we're going to use the same format, that their distance, all you have to do is take their speed in miles per hour and multiply it by the hours that they traveled. So once again, if we wanted to check, let's say Andre walked, we'll do it for both of them. Let's say for our example, we wanted to see how far they walked in 2 hours. So we're going to take, their equations, but we're going to substitute in 2 for t. And 2 7/75 times 2 is 5.5, so meaning 5.5 miles in 2 hours. And that would mean that he walked 7 miles in 2 hours. And once again, if we went back to our table, those are the correct values from the table. So once again, that's the cool thing about these algebraic expressions, is that you can represent real-world situations by using these equations, and then all you have to do is plug in the variable, and it will give you the answer. So how far did Elena walk in 2 hours? Plug that in. I know she goes 2 7/75 miles per hour. Turn the hours into 2 and multiply, and I get her speed in 2 hours. If I wanted to find out how far she walked in 5 hours, all I would have to do is substitute in 5 for my variable, and I'd get my answer. So, use the equation you wrote to predict how far each participant would walk at their same rate in 8 hours. So, we'll do Diego, Elena, and Andre. So Diego, his was D equals 3t. Elena was D equals 2.75t. And Andre was D equals 3.5t. And once again, these numbers are all coming from their speed in miles per hour. And for all of them now, I'm going to rewrite their equations, but I'm going to substitute in 8 for t. And then, so that would mean then 8 hours, 3 times 8. Diego would go 24 miles in 8 hours. Elena would go 22 miles in 8 hours. And Andre is 3.5 miles per hour, so multiply that times 8. And he would go 28 miles in 8 hours. Alright, and real quick, the question at the bottom of this page is super important. For Diego's equation and the equations you wrote, which is the dependent variable and which is the independent variable? So once again, independent means that it stands alone. It can be by itself. Nothing changes it. Dependent means that it does get changed. It needs something else to find what it is. So, in this case, the independent variable is the time. Because you plug it in to find the distance. Right? In all of these examples, I was plugging in time for t to find the d distance. I never once plugged in anything for d to find the time. So the independent is always the number that you use to substitute in. It's the variable that has the operation with it. The dependent variable is always the answer. In this case, distance. Because it relies on the time for an answer. Once again, if you're dependent, you need someone else. So the distance always needs a time to be plugged in before you can find it. Whereas the time, we can just plug in any number and then solve for the distance.